This is the pop-up notification for weld state deviation, also known as EPRI Weld S3. I am William Kiske, the narrator. Zion Filson is our team lead. Then another member is Ben Heshima and Sham Pandya. There's our mentor Nanba Saba, as well as our supporters John Tapman, David Hansen, and Greg Frederick. The objectives for this project is to implement a system to measure the current of the low wire feed motor, as well as to expand upon drip detection software to notify a weld machine user when defects or drips are present, to create a pop-up to notify any defects in the weld process, as well as create a real-time implementation of the microphone data. The requirements of this project is to use microphones and accelerometers or any additional sensors to detect drip conditions, as well as improve the LabVIEW code from the previous teams to better filter the noise, as well as display the pop-up of those issues when they're detected, and generate a report at the end of the welding run detailing what issues have been detected. Our design consists of a Hall effect sensor connected to a LabVIEW Midac that is detecting the magnetic fields around connected from a solenoid with a soft iron core. Within this, we have low current relays to be used to control where the current flow is going, as well as diodes to help control that as well. The Midac will be used to record the current of the motor. It will address the issue with low wire feed and converts the signal and gives off an analog signal. And it can also be used as a voltage source. The EPRI computer was initially given to the team where LabVIEW wasn't running on it properly. The team downloaded the necessary libraries after rebooting LabVIEW and had outside help from an experienced grad student named Shems from the University of Tennessee. The program is currently running smoothly, and more things will be added in order to reflect what the team needs coming the next senior design session. The Hall effect sensor is there to detect an increased load on the motor during the low feed conditions, because the motor will draw more current as there's a greater load applied to it. And this is done by detecting a change in the magnetic field around the wire. The solenoid is used to boost the magnetic field as previously stated, and increases the range and values that the Hall effect sensor can output. On top of this, a bandpass filter will be applied to the Hall effect sensor to filter out any extra noise from the system. As for our goals this semester, we have rebuilt the computer, we've learned LabVIEW, we've developed a contactless current sensor, and developed code to integrate the signal from that circuit, and we have also started developing the filter for the system. For the upcoming semester, we plan to build a current sensing circuit by September, fully integrate LabVIEW code, and define the issue indicator by November, filter out the noise by September as well, and develop a pop-up for the integrated user interface by October.